All right, let's see who we've got here. So many. Okay. Do I have Natalie? Natalie A is here. Good. And Alex is there. 9. Manny is here. Online. Gabriel is here online. And Manuel G is here online. All right, that's blue. And green group. Ivan is there. And Brian there. And Daniela is online. Got you. Brianna there. Fernando is he online? Oh, there he is. Okay. All right, and Leslie is online. And Michelle is online. Diego is online. Naomi is, oh wait, right there. Yep, in person. And Lewis is in person. And Natalie Z, she was online, right? Yeah, right in the middle, okay. My gosh, we actually have everybody. Fantastic. All right, I'm trying out a new microphone. Let me know how it is. I've got a fancy wireless mic now, so hopefully it captures my voice a little better and clearer despite the mask. Fernando, what do you think? I know you'll always give me an honest answer. Do you hear me better than before? Oh, I'm not hearing you. Okay, try now. Zoom is on the wrong speakers.
Yes, we can hear you.
There it is. Okay, and I can hear you. Perfect. All right, see, you plug something new into the computer and it freaks out and changes everything. Okay, I think we got it now. The wheel is turning slowly today, but it's going. We're getting there. All right. So, did I say good morning? I don't think I said good morning yet. Good morning, everybody. We are preparing for calculus, right? That's always our mission here. And so I'm trying to do two things. We've got two interlocking goals, as it were. One is to just practice those fundamental, most frequently used skills and items from algebra that you'll use in calculus. Okay? And two is to try to get a glimpse of what thinking in calculus is going to be like, and start that process now so that when you get to it in calculus, it won't all be new. Right? That's the goal. And that's why I've been pushing you in class. It's about like, let's try this. I know it's tough. I know it's difficult. You're going to have days where you'll feel I'm going to be horrendous to you, and you'll ask and be like, I don't get this, I'm confused, and I won't give you the answer. And I'm doing that on purpose, not because I hate you, not because I'm a terrible teacher. Well, that might be true for independent reasons, but it's because I want you to not only just experience what calculus might be like, but I got to get you into the habit of starting to think these things through for yourselves. Okay? So that's why I'm not always forthcoming with the full explanation. I'm not going to lay it all out. Here it is, step by step. Just walk down the red carpet and everything is there laid out for you. Okay? Because if I treat you that way, and then all of a sudden when the road gets difficult, you're going to struggle. I'd rather you struggle now, because we can help you and get you on there. You have time to work on things, all right? Whereas in college, all those resources might not be there. So with that in mind, I was thinking this morning of like, okay, what the heck is the difference in calculus? We go from algebra to calculus, and somebody decided, oh, that's too big of a jump. We'll add this pre-calc class in the middle there. Why? What's the big change? And it came to me kind of like this, and so I created this dialogue. Imagine, if you will, algebra and calculus were able to talk to each other. Algebra typically asks, what's the slope of this line? Right? You spend a lot of time finding the slopes of lines. And you'll find the equations of other things, but you never find the slope of anything but a line. And then calculus comes along and says, hey, what's the slope of this curve? Algebra then freaks out, because you can't do that. Algebra has no capability of finding the slope of a curve. It makes no sense. And calculus goes, yeah, but you could get really close. And that's what we tried to do last week with the secant line approximation. You kept getting closer and closer. And so algebra has to concede, well, okay, yes, we could get really close. Calculus's idea is this, right? If you get really, really close, like infinitely close, that's the same as being there. It's just as good. Now, the trick is that infinity part. In order for it to truly be the same, you got to go all the way up to infinity. We didn't quite go that far. Right? At this point, algebra goes, I guess, but that's a little beyond me. But calculus is excited now. There's more. There's a pattern to it. Right? If you do this often enough, you will find you don't have to guess. There's rules, there's structures, there's equations. We don't have to do that whole secant thing and get closer and closer. Well, it was like 0.1 off, and then it was like 0.01 off, and then, well, it got pretty close to 4. I guess it's 4. You don't have to try that every time. There will be a formula, an equation you can use to instantly get the slope of a curve at a point. We've worked it out. It works. Right? Even algebra could get behind that. Oh, yeah, equations, formulas. Algebra is totally used to that part. So algebra says, that's great. Where do I start? And then goes on from there. Have you ever heard of the difference quotient? Right? We'll come back to the difference quotient later. So that's what we're getting at. Right? It's that slow evolution of, hey, let's look at this. We can try to approximate it. And if we approximate it enough, we'll find that pattern to it. So we'll be bouncing back and forth throughout the year, getting closer and closer towards the actual calculus formulas. Okay? For today, then, back to those basic skills. Here's the set of algebra items you want to have mastered. Memorized is not quite the right word, but they need to come quickly and easily in your brain. Right? So the more practice you do, the more readily available they will just pop out. So our task for today is I want you to challenge yourself to basically recreate your notes from this weekend. Okay? I want you to set up 4 columns. And I've given you the list of functions on Classroom. I'll put that on the screen in a moment. Right? And for each function, write down its name. What are we talking about? Give the equation of the parent function. We are talking about the parent function here. We'll start messing with transformations and stuff tomorrow, but just parent function. Right? When I say direct variation, your brain should unlock all of the following things. Oh, a direct variation. That's the really simple equation, y equals x. Right? What does that look like? If you're a visual person, the graph probably comes to you before the equation. That's okay. The order here is not that critical, but they should all come together. And just a quick sketch. Right? Whip up some axes, That's only quadrant 1. Let's go full 4 quadrants here. Right? And it will look like that, right through the middle. That should be what pops into your head when I say direct variation. Oh, that's the line that goes right through the origin. And even better, the parent function, right? The totally untransformed y equals x. No additional numbers necessary. Means it's a 1-to-1 ratio, right? If you were to zoom into that graph, you would see at x1, you get the point y1, right? At x2, you get the point y2. And so you could create a quick list of some key points that you automatically know must be on that graph. 1, 1, 0, 0. Maybe 0, 0 should have been first, right? So it's, by definition, has to go through the origin. Make sure that's on the list. And can we go negative? Sure, we can go negative, right? Those will be on there too. So in the realm of about 3. Some of these maybe only 2 make sense, but like quick, easy numbers, what pops out onto the graph? Okay? And these were on those graphs in the notes. So yes, I'm asking you to recreate the notes again, but I'm tasking you with doing it from memory. And if not from memory, from understanding, think through it. Okay, this one has to be here. What would be the easiest to get this? All right? That is my challenge for you today. Can you recreate all this from your head based on just open this up, this list of functions. I can't zoom on this app. I'm so disappointed. Okay, direct variation, quadratic, cubic, square root, absolute value, inverse, and inverse square. The cool math guy had some more flavorful names for some of these. If that helps you, use them. But I want you to recognize the official name most of all. So let's say work on that for 10 minutes. We'll take a break and do a quiz. So we get that in, which will be same thing. It'll be matching basic functions. Here's a graph, which function is it? Here's a graph, what kind of function is it? Right? Just rapid fire, burn that into your brain. And then with remaining time, you can finish this up. All right? In the classroom, they're all nodding their heads and working away. So I'm assuming no questions. Any questions or comments from Zoom? Okay. quadratic cubic.
Mr. Apple,
Yes, sir.
uh, the quadratic, is it the standard parabola guy?
Yes. Yeah, so all of these are the parent function. They're the most standard, most basic version.
Are they in order based on like the notes that we took?
Sorry, say again?
Are they in order based on what the notes we took?
I believe they're in the same order, yes. But try not to look at your notes if you don't have to. Yeah, this one is just y equals x squared. That down there. All right, go ahead and pause where you are on that work. Come back to my screen here. Get the quizzes code. Joinmyquiz.com. Your game code is 705397. 705397. All right, and once again, this is function identification. Most of the questions are, here's the graph, what type of function is this? Just that, build in that rapid fire recognition skill here. Okay, I think we're waiting on one more. I'll give you 30 more seconds and we'll go. Hey, made it. All right. Let's begin. 78, so close. Can we push it past 80? Those of you that are finished with the quizzes, feel free to return to your table of functions. That is your only classwork for today. And when you've finished that, be sure to upload some picture thereof to Google Classroom. If you are done with that, feel free to work on anything else, either in this class. There is the study.com homework lessons this week, significantly fewer than last week. So hopefully that'll be a reasonable number going forward. And then I think that's all we got. Oh yes, as usual, a retake code. I've already queued it up to be posted at the end of the day. That will be available until the end of the day Friday. So feel free to make use of that. Hey, we did it, 80%. Nice. Let's see here. What? Ooh. 15, huh? Most challenging one. Really want to know what people said here. I can't open the answers till we're all done. All right, yeah, that's a tricksy one. That's a tricksy one. I'll give you that. All right, and Michelle takes the top spot. Congratulations. All right, let's see. I should be able to click on this now. Yeah, as suspected, a lot of absolute value. It looks like it. It's a great big V. It's similar in shape, but if you look closer, and it looks to me like they actually created this graph in Desmos, and so it kind of gives it away a bit that those two lines are two different colors and two different slopes, right? The absolute value is not just any V, it's got to be perfectly symmetrical. And so because that lack of symmetry there, it is in fact none of those functions. It is a piecewise, it is just two separate lines combined there. All right, that was probably the trick question of the bunch. All right, so we've got 5, 6, 7, 8 more minutes to work. So I'll go ahead and stop the YouTube stream here.